Welcome to a recorded training presentation from IronRidge. IronRidge is a NABCEP continuing education provider. Unfortunately, on viewing recorded training presentations, we cannot offer the continuing education credit. If you're looking for continuing education credits for NABCEP, please join us on one of our live webinars where we can be interactive and I can actually share with you any questions you might have during the training presentation. But definitely thank you for joining in here now and watching and learning a little bit about IronRidge ground mount and the IronRidge Design Assistant tool we have for ground mount. My name's Dan Felix. I work at IronRidge as the training manager. I've been here for about 3 years now. Truly, my background is as an installing solar contractor. Had my own electrical contracting firm for about 17 years installing solar. Then moved on to work with a nationwide integrator installing very large utility scale and very large commercial projects across Arizona, New Mexico, and California. It's been a phenomenal travel over the last 25 years in the solar industry. Interesting also is very shortly after I started in the solar industry, Craig Carney, the founder of IronRidge, he became approached from local people in his community that were installing solar, and very much like myself, we were struggling back in those days, trying to figure out any way to mount solar panels. We were utilizing a lot of items from the electrical industry. We were using unistrut and spring nuts and everything we knew as being an electrical contractor on how to install solar panels. And from Craig's local community asking him, with his background of a steel worker and a structural engineer, to be able to help them figure out ways of mounting solar panels. And Craig went ahead and started some great thoughts, performing a great racking system here at IronRidge. Here at IronRidge, we really drive for a high quality product in all of our product lines. And in that, it just costs money to produce a really high quality product. So we're constantly looking at ways that we can go ahead and minimize the cost of our product. One of the ways that we can achieve this is actually by producing our product at many locations nationwide. This allows us to minimize the cost of shipping to the end user. I talked a minute ago about quality and how much we really strive for high quality in our product. And it's not just us patting ourselves on the back stating we do all of this. To evaluate quality of our product, we utilize a lot of third-party organizations to go ahead and review our product. Anything that requires UL testing, we utilize Intertech, such as our integrated grounding, or all the fire testing showing that we're a Class A rated fire racking system. We utilize IATMO to evaluate some of our products. IATMO is a third-party evaluation organization. We're an ISO certified company as well. If you're not familiar with ISO, ISO is reviewing not only our product, but they're reviewing how we package our products. They're reviewing how we ship our product. They're looking at everything within the office procedures as well. So it's interesting. We are an ISO certified company. So in the quality of our product, we're very confident to be able to provide a 20-year warranty on all of our product lines. Definitely a leader in the solar racking industry for warranty periods. Definitely, our promise to the solar industry is to make solar stronger. We used to have a tagline saying, "Make solar simple," and we really strive and continue to strive to develop very simple products to use out in the solar industry. But also in that, in all of our testing procedures and everything we do, we really strive to have a stealthy, strong product. We're truly wanting to make solar stronger. So we changed up our tagline last year to definitely make solar stronger. Okay, for today's agenda, I want to go ahead and look at the lay of the land. We'll go over the IronRidge ground mount product line itself. Then I want to look at some different options and strategies that we might think of with ground mount installations and building and designing. Definitely I want to spend a good amount of time on the Design Assistant tool that we have here at IronRidge for ground mount. Awesome tool. And then definitely it's a little difficult to have questions and answers in a recorded training presentation, but certainly if you have any questions, note them down and feel welcome to go ahead and call our customer service group at 1-800-227-9523. We'd be glad to answer any questions you might have. The lay of the land. Kind of interesting as we go out and visit customers that are interested in solar, and we approach their property and we start looking at what the surrounding area has for us. First off, I see as I'm pulling up to this structure is a tile roof, and as an installing contractor, that's not my favorite right off. But I see there's a lot of open land possibilities for this customer. We immediately start thinking for the customer, here or how about here? Definitely if we're looking at that roof, we're stuck with working what I call within the box. Definitely unfortunately we're stuck with the existing tilt angle of that roof, pretty much stuck with the azimuth or the direction of the roof line to the sunlight, just the square footage, just the area we have on that roof, and having to deal with that existing structure. Yeah, I'm still looking at that tile on that roof. If we do ground mount, we can start thinking about building our own box. Definitely we can play with the size of it, the tilt angle, what type of foundations I want to build, and what type of materials I even want to use. It's kind of interesting as we start thinking about ground mount projects and the engineering implications with doing a ground mount project. Obviously, if you look at an above ground ballasted system or something like that, definitely you're going to have a lot of site surveying. If we're going to do pile-driven columns or screw anchors, I've built them both, but they take a lot of geotechnical analysis. We got to get a soils engineer out there and take some samples and really see what we have with Mother Nature's soil at the site. Structural engineering, I don't care which way you're going to go in a ground mount project, no matter what, we're going to have some structural engineering for that racking system. As we start thinking about construction implications, if you're going to do above ground ballasted, definitely you're going to have to do some site grading. Even if you're going to do a pile driven or helical coil screw anchors, more than likely you're going to be grading that site. Once you go ahead and get the site graded and prepped, you know what? It takes some stealthy equipment to pile drive columns into the ground, or even screw anchors can be difficult sometimes depending on the soil conditions. The other option, we got concrete in-ground foundations. Even the in-ground concrete foundations, as simple as they may sound, they still are going to take labor and time to get the holes dug out and to go ahead and get the concrete poured. So as we start thinking of our project, what are we really building? Are we building farms of solar, or are we just building some solar for farms? Truly, that top photo is a site that I built in Central California, a megawatt of solar. It looks pretty impressive out there. But truly, on a large project like that, you can afford to go ahead and possibly think of other opportunities in saving labor, such as pile-driven columns or something like that. But those type of projects take some very expensive soils engineering and testing to be performed to prove the strength of the soil for that type of project. For most of us, we're probably building more projects that are more of the line of solar for farms. In these size projects, it doesn't warrant those upfront costs of doing all the soils engineering. So we're going to resort, in most cases, to an in-ground foundation system. So let's take a look at the IronRidge ground mount product line. Pretty simple product actually. If you have ever installed IronRidge rails for a roof mount system, there's a lot less to learn in using our product. It's going to use the same rails and same module mounting hardware as you would for a roof mount system. Below the rails basically is what I call the substructure in a ground mount project. At IronRidge, we're going to provide you the key ingredients to make a very quick assembly of the substructure for your ground mount project. We're going to let you, the installing contractor or the customer, go ahead and provide the Schedule 40 steel pipe that's needed. There's no sense in IronRidge shipping Schedule 40 steel pipe around this nation when you can source it locally from a pipe supplier. In the IronRidge ground mount product, we go ahead and we utilize our big bad boy rail, that XR1000 rail. If you're not familiar with the XR rail family at IronRidge, join me for one of my other training events. Then we use our standard mid clamps and end clamps to go ahead and mount the modules to the rails. We do have an under clamp that's available too for ground mount. If you're doing an extreme tilt up system or possibly in some really extreme wind loading conditions, you may want to consider doing an under module clamp that leverages into the side slot of the XR1000 rail. Then it's the exact same accessories for roof mount. We have our end caps and our wire management clips. What's new to ground mount for IronRidge is the acceptance of utilizing mechanical tubing. Now you have a choice in the substructure in providing steel pipe for your project, or you can utilize a mechanical tubing. I'll tell you about more of that in this training presentation. And then we're going to provide you those key ingredients. Pretty simple product, top cap to go on your upright pier. It makes a very easy assembly of the horizontal cross member of the substructure, and then a rail adapter, very much like an L-foot but longer, that allows a U-bolt connection then of the rail to the substructure. Illustration here of a ground mount system from the north side of the array. From this illustration I can point out a few things very quickly. So we have what I keep referring to as the substructure. You have upright columns of either 2-inch or 3-inch pipe or mechanical tubing. You also then install our top caps on top of those upright piers. Then you have a horizontal cross member of Schedule 40 steel pipe or mechanical tubing that is very quickly attached to those upright piers through some U-bolts. Then you'll go ahead and apply the standard IronRidge XR1000 rails that you would use in a roof mount project, and apply those rails to the substructure, again with some very simple U-bolt attachments. So when we look at an open illustration with no modules on it, it's a little easier to see some of these key factors into the substructure. We have our upright pier and our top caps. That's holding the horizontal cross member of our substructure. Then we're utilizing the rail adapters to attach the rails to that same substructure. Then we have same module clamps, mid clamps and end clamps that we would use on a roof mount system, and we are utilizing the XR1000 rails. Here's just another diagram showing the location of these parts. There is an optional cross brace that is available with our product. The optional cross brace is most cost effective for very, very extreme wind conditions or extreme tilt-up conditions for your project. And we'll go over that in the Design Assistant tool. But as we start designing our ground mount project, we really need to be thinking about the loading forces that are being applied to this ground mount system and substructure. So we have downward forces. We have just the weight of the system itself. We call these dead loads. Then we have our snow loads, possibly for whatever location you might be at. And if we've got any southerly winds at all, we're going to have downward forces from wind. Now, the other side of that is north winds. If we happen to be in a location that's going to have a lot of north winds, that'll cause uplift forces to our ground mount system. All of these forces, whether they're downward forces or uplift forces, are being applied to the foundations. What's interesting is that an in-ground concrete foundation has more than just the dead weight of the concrete itself. It has what we call skin friction. It's the friction forces that it actually takes to pull that concrete out of the ground. So let's start thinking about some design options and strategies. Definitely we have some items at our site that are beyond our control. We have no control over what Mother Nature's throwing at us, whether it be the weather with wind loading and snow loading, or could be the soil classification, just the type of soil that we're going to be building this in. And the wind exposure category, definitely that's going to play a factor in our project as well, and we'll talk about that in the Design Assistant tool. But definitely we have things that are within our control as we're designing our system. We can build now with 3 up, 4 up, or 5 up, so we can control the height of the system. We can control the tilt angle of the system. That's going to affect the wind uplift. We can control the size of the foundations by controlling some of these other factors I just mentioned. And then definitely we have control over the materials we're going to build the system out of. So we start looking at these site factors that are beyond our control. Definitely we have no control over the wind zone. We have no control over the snow loading. Man, I'd hate to be at that location with a shovel trying to dig out. We have no control over the soil conditions, and we have no control over the wind exposure. But we do have control of the size. So let's talk about that for a second. Just the size of the system, whether we're building 3 up, 4 up, or 5 up. That's right, with IronRidge ground mount we can do 5 up now. Pretty interesting. There was a main reason why we developed this. Number one, we want you to be able to design a system with more watts per pier, being able to do 5 up. But in extreme wind loading conditions, or could be snow loading conditions, you've got some flexibility now, because if we design with 4 up or 3 up, the wind loading and snow loading situations are radically going to change. And these lengths of our primary rails are 11 foot, 14 foot, and 17 foot. We redesigned the length of our rails when we deployed the new rail family here at IronRidge, primarily designed around most common module width in today's solar market. The 11 foot rail is going to be perfect for 3 up. The 14 foot rail works great for the 4 up, and the 17 foot rail obviously is going to be our 5 up situation. If we can go 5 up, we can get more watts per pier. That's a great advantage in some locations. We have control over the materials we're going to use. We can do this in 2-inch pipe, or we can do it in 3-inch pipe. And the new change here at IronRidge is now you can also use mechanical tubing. So just remember that you have the selection of either pipe or mechanical tubing. If you're choosing pipe, be sure you're utilizing pipe and not conduit. You definitely want to be utilizing a Schedule 40 steel pipe. Conduit does not have a structural strength. Pipe does have a structural strength. We also have approved mechanical tubing. Mechanical tubing is going to be a little bit lighter weight for you out in the industry as you're trying to build your system, and yet it carries the same structural strength as Schedule 40 pipe. As we think about tubing a little bit, there is a manufacturer of mechanical tubing, Allied. We have approved their tubing to be utilized in our ground mount system. Their product comes in 3 different varieties. You can get Flow Coat, Gator Shield, or Gator Shield Plus. All 3 of these have a different amount of galvanizing on the tubing. The major difference between the 3 different varieties of tubing is that basically it's all the same tube itself, but it's a different thickness of the coating of the galvanizing protection to protect it from corrosion. So definitely if you're in that maybe a coastline area or something like that where it's very corrosive, you might want to think about using Gator Shield Plus. If you're out in a very dry, arid climate where there's very low corrosion factors, maybe you want to go ahead and use Flow Coat. Check with Allied for the tubing that you might utilize for your ground mount project. We have control over the tilt angle. Definitely that's going to make a big difference with your ground mount system, especially if you're in a high wind area. If you're in a low wind zone, it won't be too much of a difference in your foundations, but under extreme wind conditions, definitely it's going to make a difference on the size of those foundations to resist the wind uplift that's involved. So as we start looking at different loading conditions and utilizing either 2-inch or 3-inch pipe or mechanical tubing, you can see here from this chart, definitely there's some advantages to going to 3-inch. I can definitely increase the spacing between my upright piers. By increasing the spacing of my upright piers, I'm going to eliminate the number of foundations. These are choices. No need to memorize this chart because the design tool is going to perform all of this for you. Now as we start thinking of throwing some more loading in here, throw some snow loading into the project. There again, same thing. With that 3-inch pipe or tubing, you could definitely achieve larger spaces between your upright piers. There's some definite advantages at times for utilizing 2-inch though, and we'll talk about that in the DA tool. Just remember, the higher the tilt, the more piers in most cases. Alright, we have control over the foundations. As we start thinking of the foundations of our project, definitely there's different options available out there. Cast concrete blocks above ground that maybe you're designing for a brown field or something like that where you can't penetrate the soil. We have gone ahead and approved some above ground ballasted block type projects with our product, but it is a project that you would not be able to design on the Design Assistant tool. It will take a secondary evaluation from engineering groups to go ahead and approve the size of the concrete block for the above concrete block ballast weight. If you're wanting to do a pile driven upright column or a project like that, helical screw anchors, definitely that can be done as well, but it's going to take some specialty as far as the soils engineering and possibly having a screw anchor developed for the soil conditions. Definitely for most of us, we're probably just going to go ahead and design our ground mount projects with an in-ground concrete foundation. So as we start thinking about this foundation, we need to also be thinking about what Mother Nature is giving us at the site for the soil conditions. Kind of interesting when you start looking at some charts on different soil classifications and what those soils primarily are made out of. Pretty interesting over the years that I've built ground mount projects. What's also interesting is sometimes just in very slight increments of depth, the soil can change pretty radically. This is just a chart just to give you a guideline of different soil conditions and the strength of that soil under those conditions. Pretty interesting in the sites I've built over the years. The top photo happens to be a site in California. Pretty much perfect soil conditions. A little bit of clay, a little bit of sand, some fine rock, easy digging, and yet very strong soil for my foundations. Center photo happens to be a site that I built in Kingman, Arizona. And yeah, I'm laughing about it because every time I think of that project, I just about shaking my head when I showed up at the job site because virtually it's solid granite rock. Not granite rock like you'd build a countertop out of, but maybe you'd call it more of a decomposed granite. But you certainly weren't digging any foundation holes out there by hand. Literally on that job I had to bring a well driller in to dig my foundation holes. Bottom photo happens to be a site that I went ahead and built in California. Went and visited the customer, almost looked like perfect soil conditions. You know, it looked like pretty good soil. Went ahead, got the project, and we went out there and started digging the foundation holes, got about 12 inches down and hit groundwater. So a lot of different things can happen to you out on the job site with Mother Nature. Alright, as we start thinking about the different soil that we might have at the job site, basically the stronger the soil, the smaller the foundations can be. So just take note of that, and definitely as the soil classes decrease, the foundation size is going to increase to be able to have a good holding strength in the poor soil conditions. And then I'll talk a little bit more about this on the design tool, but virtually for most of us we'll probably want to design as a class 4 soil condition, worst soil possible, because when you go to the building department to pull your permit, if you choose a type 2 or type 3 soil condition, it is possible that the building department will require you to have that soils engineering performed that really we don't want to spend the money on in most cases. So in most designs on the design assistant tool that I'm going to show you, we'll probably try and leave that soil condition as a type 4. Now if you're doing a very large commercial project, it might be that it's worth spending the money for some soils engineering to go ahead and have that as part of your permit package to be able to reduce the size of the foundations in the overall project. This is where I want to go ahead and shift gears here a little bit. We've been on my PowerPoint presentation, and now I'm actually going to shift gears. We'll go ahead and get on the IronRidge website and we'll work with this design tool a little bit. We're on the opening page of the IronRidge website, but we'll go ahead and we'll go to the top of the page. You'll notice that we have the different product lines listed up here. So we're going to click on ground mount. What comes up is a toolbar off to the left hand side. There is a neat 360 view. If you've never taken the time to look at it before, you can click on the 360 on that toolbar and it'll bring up a ground mount racking system. We can go ahead and spin that around in different compass headings on this compass to the right and look at it from different angles. I've heard where quite a few people like utilizing this actually as a sales tool with a customer when they're going out to try and sell a project. So you can look at it from different angles. You can add the solar panels on there, take them off. Some nice options to be able to utilize for a 360 view of our ground mount system. Just even to look at it to see how all of the parts assemble. Okay, next item down on the toolbar is tech specs. Right here we just have some general information. You can design up to 150 mile an hour wind. You can do a tilt up to 45 degrees. Just some basic information if you're wanting to look at a few different things. We carry a 20-year warranty on the product, just like all the product line here at IronRidge. Next item down on the toolbar is our resource page. Definitely this is where we have a lot of documentation. If you want to go ahead and print out items to be part of your permit package, maybe you want to print out an install manual so that you can provide that to your crew out on the job site the first time you use IronRidge ground mount. Also right here, earlier I talked about engineering needed to be performed for just about any ground mount project you design. We're going to provide you an engineering document for your project. You can go ahead and print out your engineering document from right here on this resource page, or it's also available on the final page of the design tool. We also have other items listed down here, other third-party manufacturers that maybe you're wanting to utilize some of their product with our product. We have frequently asked questions here as well, so if you're thinking of a few questions that you have, you might want to check down here for some answers. I'm going to go ahead and click on Design Assistant, and we're going to start a project. Anyone can get on our IronRidge website and use our design tools. There's no charge for using our tool. I would suggest that you actually take the time to open an account with IronRidge for utilizing the tool. If you open up an account using the tool, it allows you to save your projects. It also allows you to share your project. There's also no charge at all for opening that account at IronRidge for using the tool. We're on the opening page of the design tools, the general page. First thing we need to do is give the project a name, and for today I'll just call it John Doe. The next item down is planning a module that we're going to utilize for the project. Truly, we have over 2,500 different modules available here. If you're choosing a module that you do not see on our design tool, go ahead and call the 800 number at customer service. It's right here on this general page, 1-800-227-9523. Literally, if you can provide our customer service group a text sheet for that module, in most cases we can get that module added to the design tool in just an hour or less. For today's training, I'm going to go ahead, I'm just randomly going to pick a module, pick a SolarWorld module for today's training. Once we've chosen the manufacturer, then we need to actually choose the module from that manufacturer that we're going to utilize. So I'll just randomly choose like a 280 watt module here. Next item down. All right, we can start planning our array. It starts off with 5 up. This is where you can make your selection of 3 up, 4 up, or 5 up. If I was designing for a very high wind speed, I would probably choose 3 or 4 up to minimize the size of my foundations. But for today's training, I'm going to go ahead and utilize a 5 up. I want to get the most watts per pier in my project. So we've got 5 modules up. That's modules side by side. They're in portrait to the rails, but they're in landscape to the ground. Remember, your rails are running north-south across the substructure, and your modules are mounted in portrait onto the rails. So we're going to go ahead and let's do at least like 8 columns of that. So when we say columns, that's a row of 5 modules, and we're doing that 8 times running east-west across the subarray. So now this may be a project you're designing for a very large commercial project. Maybe we want to repeat the same structure 20 times over. You can literally do as many repeats of this project or of this substructure design that you want. Maybe this is a large commercial project, and you want to go ahead, you've got another little strip of land, you still want to do 5 up in your modules, but in that smaller strip of land at the edge of your overall land space, you don't have room to do 8 columns. Maybe you only have room to do 5 columns side by side. So you could literally just go ahead here and keep adding subarrays. Maybe it's a big enough project where you've got 3 different substructure sizes that you want to choose from. So literally you can just keep adding more arrays. We're going to go ahead and we're going to delete this one project, and we're just going to go with the one array of 5 up and 8 columns of that. Next is our engineering page. Alright, first thing I need to do is put in the zip code of the location. I'm going to utilize where I'm at here in California. From placing my zip code, it knows exactly where I'm located and what the local jurisdiction of that area generally for that area is requiring for your designing your loading conditions, being your wind and snow loading. So from entering the zip code, it knows that for this jurisdiction, generally, I need to design to 100-mile-an-hour wind speed and that there's 0 snow loading. There are some jurisdictions that are still working off of ASE 705 structural engineering. This tool works off of ASE 710, the latest structural engineering. Under ASE 710, it's basically requiring that you design to an extreme wind speed instead of general wind speed. General wind speed, I'd be at 85 miles an hour. Under extreme wind speed for this location, I am going to design at 100-mile-an-hour wind speed. Now, if you're in an area that has canyons or a lot of elevation changes, I suggest that you contact with the local jurisdiction and validate with that zip code area and an exact street address what the local jurisdiction is requiring for your loading conditions. If they are requiring maybe 120-mile-an-hour wind speed, because with the exact street address you're down in a canyon area, you can adjust this here. Maybe you're up on a ridge where you're getting a possibility of some snow loading. You can adjust the snow loading as well. Alright, next item down is your loading conditions. We're going to leave it at 100-mile-an-hour wind speed. We're going to leave it with 0 snow loading. Now what's interesting is wind exposure. You'll notice in the tool that we have these question marks here. If you're not certain of what we're asking of you, you can always click on the question mark and we're going to give you an explanation. Interesting is that in the Modesto, California Valley area where I'm located, I could be building this system in a residential area with a lot of trees and buildings around me to break up wind in a storm event. Or I could be building this out in open farmland for a farmer someplace where I could be in exposure C type category, where there's actually nothing around me for a 3-mile radius to break up any wind in a storm event. So definitely pay attention to each of these items. They're very important as you're filling in for your location. I'm going to leave it on wind exposure B. I'm going to plan that we're building this in a residential area with other trees and buildings around me to break up wind in a storm event. Alright, the next item, and this is the most critical location here as we're designing our system for ground mount here at IronRidge, and that's our foundations. And truly this is where we have probably the most amount of flexibility and choices in the overall design of our system in working at the number of foundations and the size of the foundation. So just a word to note on is that over the years that I've installed ground mount, my sweet spot for the depth of my foundation was always 4 feet. I could rent a bobcat and an auger from my local rental yard and very easily achieve a 4-foot depth to my foundations. Let's look what we have here. The tool opens utilizing 3-inch pipe or mechanical tubing. The tool also opens at a 25-degree tilt angle. The tool also opens using class 4 soil conditions and also with a 12-inch diameter for my foundations. Now a 12-inch diameter for the foundation is pretty small. As we note some of these other items on this foundation section is we're looking at the minimum depth of the foundation right below this. And wow, it's at 6'6". As I said a minute ago, 4 feet was always the sweet spot as an installing contractor. So one of the ways that I can go ahead and reduce the depth of my foundation is increasing the diameter of my foundation. So right off, I could very easily rent a 24-inch auger from the rental yard. And now I'm at 5 feet. So wow, I got rid of 1.5 feet out of the depth of my foundation. Something else to look at here. We've got the number of piers in our project. Right now we have 8 piers in our project. Now earlier I talked about the fact that we can use 2-inch pipe or mechanical tubing or 3-inch pipe or mechanical tubing. And as we think of that, a lot of people like to use smaller dimension pipe, thinking it's lighter weight and easier to handle on the job site. So I can change this to a 2-inch pipe or mechanical tubing, but in doing that, you'll notice right off down below here, I've just doubled the number of piers that I have in my project. There's 16 piers now in my project. Something else is interesting is that by increasing the number of piers in my project, I have also reduced the depth of my foundations. Now I talked earlier about some customers that may want a shallower depth to their foundation due to the soil conditions Mother Nature has provided them at the site. Maybe they have 3 feet of good soil and then they're hitting solid rock below that. That is an advantage to going to 2-inch pipe, is that you can reduce the depth of your foundations. Now in this situation, I could reduce the diameter of my foundation to reduce some concrete and still be able to reach that 4-foot dimension. But I'm going to put this back to the maximum diameter because I want to show you a couple of other items. I am going to go back and I'm going to put this back to 3-inch pipe. I would always use 3-inch pipe unless I was building a very small array. If I was just building maybe 6 to 8 modules, something like that, maybe 10 modules, I'd probably go with 2-inch. But anything more than 10 modules, I would definitely think of switching to 3-inch. More than 4 foundations, I'm going to go to 3-inch pipe. So as I switch back to 3-inch pipe or mechanical tubing, I can see I'm back to my 8 piers in my project. That's only half as many foundation holes to dig now. I am at a depth of 5 feet. It's a little deeper than what I like to be at. One of the other ways that we can change that is the tilt angle. If I reduce the tilt angle, if I reduce that wind uplift and drop it 5 degrees, I'm at 4'6" now in the depth of my foundation. If I drop it another 5 degrees, go to a 15-degree tilt angle, you'll find that it's going to reduce the depth of your foundations more. Wow, that's great. I'm at 3'6" now. On reducing the tilt angle, you need to be thinking of a couple items. As you reduce the tilt angle, you're going to reduce probably overall annual production depending on your location. If you're in the far south, a 15-degree tilt angle may be the best place to be at. If you're in the far north, you're probably going to want to be more like a 30 or 35, maybe even as radical as a 45-degree tilt angle if you're all the way up in the very, very far north. So just take note of that. On a very small project or a residential project, by changing 5-10-degree tilt angle, it's probably not going to hurt too much in the overall production of the site. If you're doing a very large commercial project, doing half a megawatt or a whole megawatt of solar, be very careful with changing the optimum tilt angle, because in a very large project it can make a pretty big difference on the overall annual output of the site. I'm going to go ahead and put this back to a 25-degree tilt angle. That's optimum for the customer, for my location, and I would like to maintain that as possible. What are my other options? Well, is the soil classification. Now, as I told you earlier, in most cases, for a smaller residential system, I'm going to leave this on Class 4. If you go into the building department to get your permits with a Class 4 soil condition, they're not going to require any special soils engineering. But maybe you have this as a very large commercial project that you're going to build, and you have very good soil at the site, and you're going to go ahead and change that soil condition, going to spend the added money with a soils engineer to go ahead and prove to the building department what your soil conditions truly are. With class 2 soil conditions, I'm down to 3'6" on the depth of my foundations. Maybe I could actually go ahead and reduce the diameter. I can go 20-inch diameter and still be 3'6". I can go 16-inch diameter, and now I'm at 4 foot in depth. Alright, that's a pretty nice diameter, pretty shallow depth. Just take note though, with a class 2 soil condition, you're going to be requested by the building department to have soils engineering as part of your permit package, proving the conditions of the soil. I'm going to put this back on a type 4 soil condition. I'm going to go back to a 24-inch diameter foundation. I'm going to drop this 5 degrees and get at least to 4'6" with the depth of my foundations. I'm at 8 piers. I'm looking pretty good here where I'm at right now. As you look down below the foundation section, we have a section called forces. This is great information for a company if you're going to go ahead and have a screw anchor that you're going to utilize possibly for your project, or maybe even a pile-driven column if you wanted to attempt that. This is information that would need to be shared with the soils engineer and the screw anchor company as far as the forces that are going to be applied against that pier in the project. Next page is the layout page of the design tool. On the layout page, this is critical for when you install your project. It's going to give you all your subarray details as far as all your spacing for your piers. It's going to give you your edge clearance. It's going to give you everything you need for knowing the total area space of building your project. Alright, the next item down is going to give you all your substructure information. It's going to give you the exact length of the pipe or tubing that you're going to need for your project. Note on one item here is this does not account for wasted pipe. So let's say you're buying your pipe from a pipe supplier. Generally that comes in 21-foot lengths, and as you're cutting the needed lengths of pipe for your north and south piers, out of that 21-foot section of pipe, you're probably going to end up with some wasted pieces. So just take note of that and add accordingly for any cut waste that you're going to have in your overall project. You'll see here that like on the north pier, we have a total length of that pier being 8 foot 3 inches. You're going to have 5 foot 3 inches of it above ground, and you're going to have 3 feet of that pipe in the concrete foundation. It shows that for the south pier as well. It also provides you the horizontal cross member length that's needed in your substructure. It's important to note here the overall length of that pipe and what's needed. When you purchase pipe, you can purchase as non-threaded or threaded pipe. If you order enough threaded pipe to be able to screw the pieces of pipe together with the coupling that's provided at one end, you'll be able to go ahead and assemble the pipe at a length that's needed for that horizontal cross member of the substructure. If you're utilizing mechanical tubing, you'll need to request with the mechanical tubing company that you're purchasing the product from to provide you enough splice pieces. The splice pieces for mechanical tubing slide right into the dimension of the tubing that you're utilizing, and then you'll use a self-tapping screw to assemble that splice piece into the tubing. Then you'll slide your second piece of pipe onto that first piece of tubing. Actually, the tubing works pretty slick, quick assembly of splices. Alright, kind of an added little feature down here at the bottom is we're going to actually provide you the number of yards of concrete that are needed for your foundations. Just saves you the math of figuring out when you're ready to order your concrete from your concrete supplier. So in this project, with the 8 piers that I have at 4'6" depth, I need a total of 4.19 yards of concrete. So just some nice information there on the layout page. Alright, the next page is the quotation page. At the top of the quotation page, we're going to give you some project details that are kind of useful, and you should take note of. It's just giving the tilt angles and the number of modules you have, the concrete foundations. The next item down is your options. Definitely I would utilize T-bolts. Definitely get some wire management clips for managing my wiring as I'm performing that. The IronRidge wire management clips snap right into the top of the XR rail. Definitely with that body shape of our XR rail, I would utilize the end caps to go ahead and prevent those leaves or debris from getting into the ends of the rails. The clamps, you have a choice of the finish. Could go ahead and maybe you're doing black modules, maybe you want black for your module clamps. You can make that selection there as well too for your options. Alright, next item down, we're going to provide you a complete bill of materials for your project. No sitting at the office table planning all the nuts and bolts and everything you might need. We're going to provide you a complete bill of materials, and in that you can edit items if you need to. Maybe you're wanting an extra top cap, maybe you're wanting some extra end module clamps. You just go ahead and click on edit, and you can go ahead and add some or subtract some, whatever you want to do, and then hit save, and it's going to go ahead and itemize that for you. The next item that you can work on is everything right now is suggested manufacturer resale price. Whichever one of our distributing partners you're purchasing our product from, they're going to give you some type of great discount off of suggested manufacturer resale price. I'm going to be very conservative here. I'm going to go ahead and I'm just going to put a 25% discount in. I'm sure you'll get much better from that on any one of our distributing partners. But you put your discount level in there, hit apply, and now we're going to provide you suggested manufacturer resale price, but we're also going to give you the actual price that you're going to purchase the product at. We actually give you the shipping weight as well. Maybe you've got some special shipping requirements for the job site, and you're needing to know the exact weight of the product that's being shipped. The next item is our next steps page in the design tool. On the next steps page, this is where you can go ahead and share your project with another user if you have an account here. Just take note that when you share your projects, you don't share them out across the internet. You share them basically like on a cloud here at IronRidge, and the only people that'll be able to view your projects as you do your designs will be the people that you place their email address into. Now, that person that you want to share your project with, they will also need an account with IronRidge for the design tool. But once they also have an account with IronRidge for using the tool, then they can get on our website and view your project. So I highly suggest that you work with your distributor, ensure that you're able to share your projects with them. This way that once you complete your design, you can just call up your distributor, let them know that you've shared a project with you and you want to go ahead and order that material for your project. Just a great way of being able to work with your distributor for ordering the product. Also, you can go ahead and print your project. You can download the project into a CSV file if you want. Just some great items you can do here. Now, I talked about the engineering document. Remember, just about every ground mount project will always have to have some engineering with it. We're going to provide you a third-party engineering certificate for your project. Go ahead and choose what state you're located in. We have engineering documents for 38 states and 3 countries. Go ahead and choose the state or location that you're at. Next up is planning the design that you've done. We did a 5-up design, so I'm going to click on 5-up, and you'll hit download. It's going to download a third-party engineering document from a company called SML out of Arizona. It's going to open with a cover page for your engineering document, and then it goes through a huge number of charts. Don't kill a tree by printing out this document right away. Go ahead, download the document, just select the charts that are pertinent to your design. You'll notice that these charts go through different soil classifications. They'll go through different wind exposures. Just definitely, there's probably only about 8 charts that you need to print out for your specific design. Just print out the charts that are pertinent to your design. Is a review of their calculations, and then an actual stamped document that you can go ahead and have as part of your permit package. Definitely a great document to have. The next item basically below that is some detailed drawings. I would definitely print out these detailed drawings, not only for the permit package, but then I would have them with your installers out on the job site. If you have an inspector that's on the job site and he's questioning how something is installed, you can show them the detailed drawings and show them that you've installed it just per the manufacturer's requirements. So a great document there for you to print out and have as part of your permit package and to have on the job site with you. Installation manual here, if you're looking for that. Just saves you from having to go back to that resource page to be able to print out an engineering document for your project. This next steps page of the Design Assistant tool is the final page of the tool. You can go ahead and hit save and close down here. As long as you have your account, You can come back to your project later. Maybe you're going to take this out and visit the customer and they want to do an even larger system. By saving your project, it makes it very easy to come back to your existing project and make your needed changes. Also, it makes it really nice if you've already designed a project for one customer and you're going to build basically the same size system again. You can go ahead and just change the job name and boom, you immediately have another project designed for that new customer. At this point, I'm going to go ahead and go back to my PowerPoint presentation and let's complete going through the different slides I have on install notes. Let's look at some options with our installation. As you're going ahead and planning your project, no specialized concrete to order with your concrete mix. Regular 2500 psi concrete. Literally, you could get sack concrete, take it out to the job site and mix it yourself. But truly, it's going to be a much faster way if you just order concrete and have it delivered to the site. Remember that you can use steel pipe or mechanical tubing. Definitely do not use conduit. Conduit does not have a structural strength. And as we speak on that note, some other things that you really need to think about a little bit, and if you are going to utilize tubing for your substructure, I will show you a slide here in a minute. We're going to talk about the torque value of those set screws in those top caps. But definitely you have the option of using Schedule 40 steel pipe from a pipe supplier or utilizing mechanical tubing. Alright, as you get out to the job site, measure it twice and only dig it once. Make sure you got your locations proper and go ahead and dig your foundations. As you dig your foundations, definitely I found that working with a bobcat and an auger, even if you have to rent the equipment for a day, was truly the best labor savings ever. The bobcat and an auger can really dig those foundation holes quite quickly. You'll find in most cases, about every case, that either the one-man auger or a two-man auger will not be able to auger a foundation depth or diameter large enough for your project. And definitely don't want to be like the bottom photo on the left. Definitely don't want to be out there digging them by hand. I will note one other thing to think about as you're going out for your site evaluation and meeting with your customer. I used to carry a small auger, a fence post auger, one-man auger, in my truck when I'd go out and do a site visit for a ground mount project in the location where the customer wanted to build the array. I would go ahead and auger several different holes into the ground at the depth that I felt was going to be needed to achieve for the foundations. This allowed me to do basically just some experiment drilling, making sure that I wasn't running into large rocks or boulders, or I wasn't going to have an issue with getting down 3 feet with my foundations and hitting groundwater or solid rock. So just a thought as you're going out and doing your site evaluations. The other item that I learned over the years was a really good way and very labor savings way of building my substructures. Basically, I would take some 2x4 lumber and bolt them together with some carriage bolts to make an X formation. By building these X formations of lumber, it allowed me to auger all my foundation holes, then come out to the job site with all my material pre-cut and pre-assemble my substructure and support my substructure over the foundation holes pre-assembled and ready for concrete. Truly, this worked out very well as we started implementing this type of application. Also, what we learned is that by just closing up the X formation of lumber, it took up just a small space in my warehouse, and the next time I had a ground mount project, I was ready to go. Virtually, we reused the same lumber over and over again on many projects. So there is the added cost of the lumber, but once you've achieved that lumber and set it up for your projects, that you can utilize it many times over to set up your foundations for ground mount projects. I've been teaching this application for a while now, and truly I've had quite a few contractors sending me back photos of utilizing this same method and finding that it worked very well for them, made a very quick installation of their ground mount projects. Really important to note is the torque setting for the top cap of the upright piers. Makes for a very quick assembly of that top cap to the upright pier with just some simple set screws. But it's very important that even if you're using steel pipe, that you tighten these set screws to a proper torque setting. Go ahead and tighten these set screws to a full 240 inch-pounds of torque for the set screws on the upright pier. Now, I'll also note that if you're using mechanical tubing, it's important to note these torque values. The torque values are different for the mechanical tubing. For 2-inch tubing, it's 11 foot-pounds of torque. For the 3-inch tubing, it's 16 foot-pounds of torque. So it's very important that this connection, as simple as it is that it's installed properly. The next item is the connection of the rail adapter to the rail. Very much like I said, like an L-foot, it has 2 3/8 bolts that are going to slide into the rail channel, and then you'll go ahead and utilize a U-bolt to attach the adapter plate to the actual substructure. The 2 3/4-inch bolts that are in the rail, you want to tighten those to 236 inch-pounds of torque. For the 2 U-bolts that are attaching the rail adapter to the substructure, truly you don't need a lot of torque on these U-bolts, 5 foot-pounds of torque. So let's talk about some assembly methods. We can do pre-assemble of modules onto the rails. We call that panelizing, and we'll go over a couple slides with that. But definitely, as you go ahead, in most cases probably going to attach the rails to the substructure and then go ahead and mount modules onto the rails. Start with a bottom row of modules and then work from the north side of the array, reaching over the width of the module to install the next module. Don't do as per this bottom photo and climb around on top of installed modules to install your next row of modules. Definitely use a ladder from the north side. It's very easy to reach over the width of a module to go ahead and install your mid clamps between modules. And let's share a little information on a pre-assembly method. So when I talk about pre-assemble of modules onto the rails, this becomes very valuable in very large commercial projects for ground mount. I would pick a remote location at the job site, set up some sawhorses, and then be placing the rails down on some jigs on the sawhorses that are going to align my rails in the correct position and install my modules on the rails. Then I'm going to load this pre-assembly of modules onto a flatbed trailer, and I'm going to transport these pre-assembled modules through the array area, installing 4 or 5 modules at a time onto my substructure. This works very well. It makes for a very rapid installation of ground mount. You can go ahead and get some of your pre-wiring done. You could actually, if you're using microinverters or power optimizers, you could get those pre-installed onto the rails. It just makes for a much quicker installation for large projects. So what's critical is that you understand and know exactly what the dimensions are between your horizontal cross members, both north and south, of your substructure. This is going to vary depending on the tilt angle that you're building your array at. So just be knowledgeable and plan out for that distance between your horizontal cross members of the substructure. Then set up your jigs on your sawhorses to where the rails will drop into place. You'll be able to have a spot in your jig on the sawhorses that shows the location for the substructure attachment, the rail adapters. What's critical in setting up this jig for the rails is to set up a jig that will be square, that you can just very rapidly, I would probably build this jig with a couple 2x4s, but go ahead and maybe a little bit of plywood, but go ahead and very rapidly be able to drop your rails right onto the jig so that they're perfectly square and perfectly straight. And then go ahead and install your modules onto those rails. Definitely you want to make sure it's true, square, and correct before you bring them out to the job site. Thank you very much. I'm glad you could join in on this recorded training presentation. As a reminder, if you're looking for NAPCEP continuing education credits, join in on one of my live training presentations where I can share those credits and a certificate for that. If you're questioning anything that you learned today and you have some more questions, go ahead and call our tech support group at 1-800-227-9523. They'll be glad to go ahead and help you with any questions you might have with the overall ground mount product line here at IronRidge. And a couple other closing thoughts. Definitely try and make time to join in for a live training presentation. In those live training presentations, I can interact and answer any questions you might have while the thoughts are coming across in my training event. If you haven't attended before, go ahead and try and join in for a roof mount training. Maybe you want to think about the codes a little bit with solar. Definitely, if you are not familiar with the overall XR Rail family, join me in a training on that. In those NAPCEP certificates, generally they get sent back out to you within 5 business days. Or go ahead and email me if you have any questions with training here at IronRidge. dfelix@ironridge.com. Thanks for joining in.